In this question, we have the method of cylindrical shell to find a volume generated by the region bounded between these, and we're going to revolve it about y-axis. You can try to visualize this guy. And you can find the intersection between them. So to find the intersection, you have y equals to x squared, y equals to 4. So just plug that in here. X squared is equal to 4. So x is plus minus 2. But note that x is equal to 0, so we should be careful a little bit. Take a look. If I graph this guy, y is equal to x squared. And then y is equal to 4, which is parallel to x-axis. And x equals to 0. So when x is equal to 0, the next line segment that you see is just right here. So you're basically taking this object and revolving it about y-axis. So this is your object, but it is in 3-dimensional. So let us give it a little bit of volume by using these dots. And then the question says use the cylindrical shell method. To use the cylindrical shell method, we need to find the circumference of the base and the height, right? So suppose this is just one of the shells that you're looking at, and it should be a little bit move over the other side to have a better visualization. Let me see. Not that bad. Suppose this is one of the representatives, am I right? So you want to find the base and multiply it by the height, the area of the base. We're not using washer method, we're using shell method, everybody. So here you need to have the circumference of the base. For your base, what do you have? You have 2 pi times x, because this guy, this radius is changing as x is changing. The distance between 0 and x. So you can just shift this guy down here to have a better visualization. And then for the height, well, what is the height? The maximum y value is 4 on top, and the minimum y value is located on your parabola minus x squared. So it's not that difficult to set it up. The volume using the shell method is equal to the definite integral. So x ranges between 0 to 2. The maximum value that it takes is 2, 0 to 2. And you have 2 pi x, which is the circumference. And then times the height. The height is 4 minus x squared. And the rest should be very easy for you. You distribute x into parentheses and then calculate this definite integral. So distribute this x into parentheses, and this guy is equal to 0 to 2, 2 pi 4x minus x cubed dx. So the volume in terms is equal to 2 pi. Then here you take the integral of 4x, which is 2x squared, minus 1/4 x to the fourth. X ranges between 0 to 2. But again, as usual, we're not really worried about 0. Just plug in 2. You have 2 pi times 2 times 4 minus a fourth, 2 to the fourth, or 16. So you have 2 pi times 8 minus 4, or 8 pi. So this is the volume of this object that we are trying to calculate. In this question, we want to apply the shell method and rotate the object about y-axis. So shell and y-axis. Let's visualize this. This is y equals to x squared minus x cubed. So let us find the intersection. Since y is equal to 0, wherever you see y, just plug in 0. You get x squared minus x cubed equal to 0. Factor out x squared, you get 1 minus x equal to 0. So x is 0 and x is equal to 1. Okay, perfect. Let us do our best to graph this guy. And here we go. When x is equal to 0, you have 0. If you plug in a half, so at 1, it becomes 0 again. But if you plug in a half, see what you get. You have a half. I'm doing just the algebra. A half to the second minus a half to the third. I get a fourth minus 1/8. And if you take common denominator, you get 2 minus 1 divided by 8, or 1/8. So it says, hey, my graph is just right here. At a half, I should have 1/8. So this is the behavior of this object that you're seeing, approximately. Okay. And then it says y is equal to 0. It means that you're dealing with x-axis. Perfect. So let me erase this guy to avoid any confusion. Very good. So far, I have y equals to squared minus x cubed. And then I have down here y equal to 0. I'm rotating this object along y-axis. Here we go. So to give it a little bit of dimension, we're using these dotted lines to show that, hey, this object is rotated about y-axis. All you need to do is to find the circumference of your shell and then find the height, and then you're done. So this is a typical shell that you're using, and then you want to find the circumference of the base. This is a base, right? What is the radius of the base? The radius of the base is just located on x-axis, the distance between the origin and this guy here, which is on x-axis. So this is x. Why it jumped? Sorry, guys. I hope it saved our work. It didn't. That's fine. One more time. At least it was saved on the video. We're thankful about that. So this is our object, approximately like this. And then this guy here. And we're rotating it about y-axis using the shell method. And we look at a random shell representing the small volume, then we are adding those volumes together using the definite integral. So again, if you look at your base here, this is the base. You want to find the circumference of the base. To find the circumference of the base, we need the radius. The radius is the distance between the origin and this point, which is on x-axis. So the volume, which is the definite integral 0 to 1 of the circumference or the length of the base is 2 pi times x. Now you need to multiply that by the height. But the height is the maximum y value, which is x squared minus x cubed, minus this guy, which is just 0. So we are not worried about anything. Then we take the integral with respect to x. Make sure to distribute x into parentheses. So the volume is equal to definite integral 0 to 1, 2 pi x cubed minus x to the 4th dx, which is 2 pi 1/4 x to the 4 minus 1/5 x to the 5th 0 to 1, or the volume is equal to 2 pi times, if you plug in 1, you get 1/4 minus 1/5. The other guy is just 0, so you get 2 pi divided by 20, or pi over 10